Students, welcome back. In today's lecture, we'll be discussing about the introductory part of our Raman spectroscopy. तो आज हम देखेंगे रमन स्पेक्ट्रोस्कोपी क्या चीज है, किस इफेक्ट की वजह से हमारे पास रमन स्पेक्ट्रोस्कोपी आया और रमन स्पेक्ट्रोस्कोपी को किसने इन्वेंट किया। तो जब आप यहाँ पे देखेंगे, द नेम ऑफ दिस टेक्निक इज itself is Raman spectroscopy. Raman, so these spectroscopic techniques were given by the one of our great Indian scientists, that is C.V. Raman. So the spectroscopic techniques were developed by the one of our great Indian scientists, that is C.V. Raman, and by the name of this scientist, the name Raman spectroscopy were later on put up. So in this today's lecture, we will discuss about the introductory part of the Raman spectroscopy, and we will know about some important concept, that is about, for example, we will see what we mean by light scattering. Then we will see about some important concept usually used in Raman spectroscopy, that is our Stoke lens and anti-Stoke lens. तो देखेंगे, हम स्टार्ट करते हैं कि ये जो स्कैटरिंग ऑफ लाइट क्या चीज है, और स्कैटरिंग ऑफ लाइट से कैसे हमारे पास रमन इफेक्ट डिस्कवर हुआ, और रमन इफेक्ट के बेसिस पे हमारा रमन स्पेक्ट्रोस्कोपी इसके बेसिस पे चलते हैं। ठीक है, तो सिंपली हम स्टार्ट करते हैं स्कैटरिंग ऑफ लाइट से। मींस व्हाट वी मीन बाय स्कैटरिंग ऑफ लाइट। स्कैटरिंग ऑफ लाइट मींस, for example, when a light radiation, if we are talking in about spectroscopy, the light radiation here means the electromagnetic radiation. So जो भी electromagnetic हम radiation use करते हैं, whether it is IR, usually we use in vibrational spectroscopy, or microwave radiation, which we usually use in case of our rotational spectroscopy. तो कोई भी रेडिएशन जब आपकी किसी पार्टिकल्स के साथ इंटरेक्ट करते हैं, तो क्या होगा, the light can be scattered after striking on that particles. For example, we have a particle. ये हमारे पास एक पार्टिकल है. This particle can be electron, it can be an atom, or it can be a molecule. Simply, we are just we are just taking it. It is a simple particles. Here, particles mean it can be any electron, it can be an atom, it can be a molecule, it can be other charged particles. ये आपका charged particles भी हो सकता है, और simply it can be a neutral particles without any charge. So we will see later on what kind of effect we usually get when our electromagnetic radiation interacted with electron, with atom, with molecule, with charged particles, and with neutral particles. Because when your electromagnetic radiation interacted with such kind of particles, different kind of effect can be observed depending upon the nature of the particles. What kind of particles are these with which the electromagnetic radiations are interacting. So when we are saying that when an electromagnetic radiation, here light means when a light rays or electromagnetic radiations interacted with the particles, the light can be scattered or reflected from these particles. But there are certain conditions that the light, with the certain amount of energy, the light are striking with these particles. After the interaction of this electromagnetic radiation with these particles, the light can scatter with different amount of energy depending upon the nature of the particles, or depending upon the interaction of these electromagnetic radiation with these particles. So यहाँ पे कुछ चीजें आपको ध्यान रखना है। कुछ चीजें जो बेसिक कॉन्सेप्ट हमने ऑलरेडी पढ़ के आए हुए हैं, जैसे कि हमारे पास रिफ्लेक्शन है, वो अलग कॉन्सेप्ट है, रिफ्रैक्शन है, वो अलग कॉन्सेप्ट है। हियर वी आर डिस्कसिंग अबाउट द स्कैटरिंग ऑफ लाइट। स्कैटरिंग ऑफ लाइट, जब आपका लाइट किसी पार्टिकल्स पे पड़ेंगे, तो वो पार्टिकल्स पे स्ट्राइक करने के बाद वो डिफरेंट डायरेक्शंस में लाइट स्ट्राइक होंगे, डिफरेंट डायरेक्शन में लाइट क्या होंगे, डाइवर्ट होंगे। तो उस प्रोसेस को हम क्या कहेंगे, scattering of light. Now, once your light gets interacted with these particles, two important phenomena can occur here. दो बहुत बड़े इंपॉर्टेंट फेनोमेना यहाँ पे हो सकते हैं जब आपका ये जो इलेक्ट्रोमैग्नेटिक रेडिएशन है इस पार्टिकल्स के साथ स्ट्राइक करते हैं, तो यहाँ पे दो इंपॉर्टेंट फेनोमेना ऑकर हो सकते हैं. नाउ लेट्स ट्राई टू एक्सप्लेन दिस इंपॉर्टेंट फेनोमेना, and what we mean by that important phenomena is the one is our elastic collision. Elastic collision. So the interaction between this electromagnetic and radiation and these particles can be elastic. The another important concept is our inelastic collision. Inelastic collision. So now let's see what we mean by this elastic collision and inelastic collision. So simply, the elastic collision means here that the electromagnetic radiations are striking on these particles, and after striking these particles, these radiations are scattered under different directions without change in the energy of this radiation. So what we mean by elastic collision here is that this is a particles, the electromagnetic radiations are striking on these particles, and after striking these particles, the light scatters under different direction without changing the energy of this radiation. For example, if I consider the frequency of this electromagnetic radiation is mu, then the energy of this scattering radiation will also be mu. It means I can say that there is no exchange of energy taking place between the electromagnetic radiation and particles. So here I can write no exchange of energy occurring between electromagnetic radiation and particles. So the particles can be any of this thing which we have mentioned here. Later we will see what kind of interaction occurs when the particle is an electron, it is an atom. So different kind of interaction or different kind of phenomena we can observe depending upon the kind of particle. So that first term, that is the elastic collision. Elastic collision means simply the electromagnetic radiations are interacting with these particles, and without changing without undergoing any change in the energy of this electromagnetic radiation, the electromagnetic radiations or light are scattered in under different direction, which means we can say that the frequency of the incident radiation and the scattered radiations will be set. So I can say here mu is equal to mu scatter. So mu incident is equal to mu scatter. So such kind of interaction are known as elastic interaction. Now, the second kind of interaction could occur here is the inelastic collision. Then what we mean by inelastic collision here is, inelastic collision means when your electromagnetic radiations interacted with these particles, this is our electromagnetic radiation, and these electromagnetic radiations are interacting with these particles. After striking these particles, there will be change in the energy of the scattered rays. So two kind of phenomena can occur here. If this is the mu, or mu is the frequency of this electromagnetic radiation, we can express the electromagnetic radiation in terms of frequency, in terms of wave number, in terms of energy. So any unit we can take here. So in inelastic collision, what will happen here is there is exchange of energy. Exchange of energy occurs between our electromagnetic radiation and the particles. So there is interaction occurring between the electromagnetic radiation and the particles, and after interaction there is a change in the energy of this electromagnetic radiation is occurring. It means the energy of this particle can either increase or the energy of this scattered radiation can decrease. If there is an increase in the energy of this electromagnetic radiation occur, it means these particles are giving up their energy to this scattering electromagnetic radiation. And in the otherwise, if the energy of this scattered radiation decreases, then it means that the particle is absorbing energy from this electromagnetic radiation. So these two important concepts we will be using later on to explain the Raman spectroscopy or the Raman effect. So we have two kind of collision can occur here. One is elastic collision, in which there is no exchange of energy occurring between the electromagnetic radiation and the particle. And in the second case, there is exchange of energy occurring between your electromagnetic radiation and the particles. So based on these two phenomena, that is our elastic collision and inelastic collision, we can get different kinds of other phenomenon also. The first kind of phenomenon is usually known as Rayleigh scattering. Rayleigh scattering, which is very important phenomena in our Raman spectroscopy. The second phenomena occurs based on whether the interaction is elastic or inelastic is our Campton effect, which we have already studied in our earlier classes. So let's see what we mean by this Rayleigh scattering and Campton effect. The Rayleigh scattering usually occurs when the particle is a molecule. It means here the scattering, the striking particle is a molecule. So this is important. In case of Rayleigh scattering, the particles with which the electromagnetic radiation is striking is a molecule. So this is very important, and you should know about the striking particles. What kind of striking particles are this? So here, what will happen when your electromagnetic radiation interacted with this molecule? And the light or electromagnetic radiation scatters without changing its frequency. Means here, if is the mu is the frequency of the incident radiation, the scatter radiation which will also have the same frequency, that is mu. So in case of Rayleigh scattering, there is no exchange of energy occurs. It means the Rayleigh scattering is an elastic collision. The Rayleigh scattering is an elastic collision, means there is no exchange of energy occur between the electromagnetic radiation striking on the particles or on the molecule, and with the same frequency, the radiations are scattering. But on the other hand, what we mean by Campton effect is here the particle is a charged particles. The striking particles will be a charged particles. Charged particles means here I will take the example of an electron, because electrons has a negative charge. What will happen here is when the electromagnetic radiation strike these particles, particle here is a charged particle, which we can say it is an electron. What will happen here is when after striking this electromagnetic radiation with the charged particles, the energy of this scattering light will decreases. For example, if I take the frequency of the incident radiation is mu, and I can take the scattered radiation is mu bar, then we can say then the frequency of this striking radiation, incident radiation, will be greater than the frequency of this scattering radiation. So here I can say that the Campton effect is an inelastic phenomenon. It is an inelastic phenomenon, means there are energy exchange taking place between the electromagnetic radiation and the particles. The particle is an electron, which means it's a charged particle. So these two phenomena you should keep in your mind, what we mean by a Rayleigh scattering and what we mean by Campton effect. Now, what is important for us here is the Rayleigh scattering. The Campton effect we are not using or it is not applicable in case of our Raman spectroscopy. So Campton effect का हमारे यहाँ पे कोई ज़्यादा application नहीं है, काम नहीं है. हमें जो important concept चाहिए, that is based on our Rayleigh scattering, and from the Rayleigh scattering our Raman effect arises. Now let's see what we mean by Raman effect. Raman effect. So let's see what we mean by this Raman effect. Now we have seen in case of Rayleigh scattering that it is an elastic collision. ये हमारे पास एक elastic collision है, और यहाँ पे आपके electromagnetic radiation और molecule के बीच में कोई exchange of energy नहीं होता है। नाउ यही इसी जो रेले स्कैटरिंग से हमारे पास क्या आता है, रमन इफेक्ट अराइज होते हैं। और ये जो रमन इफेक्ट है वो वेरी रेयर केस में ही होते हैं, और आई कैन से द रमन इफेक्ट इज वेरी रेयर। अब now let's see what we mean by then this Raman effect. Raman effect is a kind of relay scattering, but in case of Raman effect, the collision between the electromagnetic radiation and the molecule is inelastic. So the Raman effect is very rare. So it's a kind of relay scattering, means here is a particle, the particle is a molecule here, molecule here. So what will happen here is the electromagnetic radiations interacted with the molecule, and after striking this molecule, here an inelastic phenomenon will occur. Inelastic phenomenon will occur, which means that the Raman effect is a kind of inelastic collision, but here the striking particle is a molecule. That's why we are saying that this Raman effect is very rare. Means sometimes it occurs in 1 in million. वन इन मिलियन मीन्स लाखों में हमारे पास एक बार ही रमन इफेक्ट क्या होता है, ऑकर होते हैं। क्योंकि यही रमन इफेक्ट जो है वो लाइट स्कैटरिंग, रिले स्कैटरिंग से अराइज हो रहे हैं। डिफरेंस क्या है, हमारे रिले स्कैटरिंग में हमारा इलास्टिक जो है कोलिजन हो रहा है, कोई एक्सचेंज ऑफ एनर्जी नहीं हो रहा है। लेकिन रमन इफेक्ट में आपका कोलिजन जो है, यहाँ पे भी जो स्ट्राइकिंग पार्टिकल्स है वो एक मॉलिक्यूल है, लेकिन जब आपका इलेक्ट्रोमैग्नेटिक रेडिएशन इस मॉलिक्यूल के साथ स्ट्राइक करते हैं, देन द स्कैटर लाइट will either have the energy greater than the energy of this incident radiation, or the energy of this scattering radiation will be lesser than the energy of these, I can say, this incident radiation. For example, if this is the energy, and energy visually we can represent by h mu, then I can say the energy can either rises. If I can represent this arrow is the rise in the energy of this scatter radiation, then the energy will be rise by an amount of, for example, I will write it as h mu plus delta E. Or the energy, either the energy of this scattering radiation can be decreased as compared to our incident radiation, which I can represent here as h mu minus delta E. So the Raman effect, again, I am saying the Raman effect is a very rare effect. Here again, the molecule is striking particles, and this electromagnetic radiation after striking this molecule, the energy of this scatter radiation can either increase or decrease. Now, what will happen here is, if the energy of this scatter radiation increase, what will happen? The energy of this molecule, the energy of this molecule will decrease by delta E amount. It means that the molecule has transferred its energy to this scattered radiation, and this much energy are supplying by our molecule. And similarly, if the energy of this scattering radiation is decreased by this amount, it means that the molecule is absorbing delta E amount of energy from this incident electromagnetic radiation, and this phenomena is known as Raman effect. And based on the Raman effect, our Raman spectroscopy works. So what will happen here is, I can say that electromagnetic radiation can either induce change in the when these electromagnetic radiations strike with this molecule. What will happen is, this electromagnetic radiation will induce change in the rotational as well as vibrational energy of the molecule. So it will induce this electromagnetic radiation because it is changing the energy of this scattered light, yeah, light scattering from this molecule, then it means that this electromagnetic radiation will induce change in the rotational as well as vibrational energy of the molecule. Now, let's try to see this energy change in some graphically, and what we mean by Stokes and anti-Stoke lines, I will show you here. So, for example, this is our energy levels. It is n is equal to 0, n is equal to 1, n is equal to 2. What will happen here is, for example, we have a molecule here is here at n is equal to 0. So what will happen is, after striking this electromagnetic radiation with this molecule, the molecule will go under excitation to somewhere. This I can say this is virtual energy level. So any energy level, this molecule will undergoes transaction, or this molecule, by absorbing this much energy, it will undergo transaction to any higher energy levels. But what will happen is, after the getting the certain amount of energy, and it after being in this energy level for a while, I can represent the energy here is h mu. This molecule will again come back to lower energy levels. Now the molecules will sit in energy levels in n is equal to 1, and this much energy, that is energy difference between our n is equal to 0 to n is equal to 1, will what I can say will be absorbed. Absorb it means, now the energy of this transaction, I can represent it is the energy E is equal to h mu minus delta E, and this much amount of energy is giving off or by absorbing by these molecules. So this much energy is absorbing by the molecule, and the energy of the scattering radiation is decreased, and the energy of this scattering radiation is decreased, and this radiation, which has lower frequency or lower energy as compared to our incident radiation, is known as Stokes radiation. Stokes radiations are also known as Stokes lines. Stokes lines. Now, if someone asks you about the Stokes lens or Stokes radiation, how you can explain this is, radiation scattered with a frequency, I can write radiation scattered with a frequency lower than that of the incident radiations. Yeah, incident beam is referred to as Stokes radiation or Stokes lines. So what do we mean by Stokes radiation is the radiation scattered with a lower frequency than that of the incident radiation is known as Stokes lines or Stokes radiation. It means in this case, the molecules are absorbing some energy of this incident radiation. So this radiation is known as Stokes radiation. Now, another case is our anti-Stoke lens. So what do we mean by anti-Stoke lens? Again, anti-Stoke lens, in case of anti-Stoke lens, what will happen is n is equal to 2 or so on. So in anti-Stoke lens, what will happen is, for example, a molecule having an n is equal to 1 energy state will undergo transaction to any higher virtual energy levels. So this molecule is undergoing transaction to this, and after with this certain amount of energy, that is h mu, and after certain amount of time, what will happen? This molecule will again come back to lower energy levels, and in this case, the molecule will not set in n is equal to 1, but it will return to n is equal to 0. Okay. Here, what will happen after this molecule undergoing transactions to higher energy state? It will, after a certain amount of time, it will come back to lower energy level. Now, instead of this, I can say this energy level, first energy level, it will return to the lowest energy state, that n is equal to 0, and will release an amount of energy which is equal to h mu plus delta E. So this much of we can say that the scattered electron, the energy of this scattered electron is increased by delta E amount. So this scattered land in which the frequency of the or the energy of the scattered land is higher than our incident or incident radiation is known as anti-Stoke length. So these lines or this radiation, anti-Stokes radiation or anti-Stoke length. So how we can explain this anti-Stoke length, that the radiation scattered with a frequency higher than that of the incident beam or radiation is known as anti-Stoke length or radiation. So in case of anti-Stoke radiation, what will happen here is that the radiations are absorbing some certain amount of energy from our molecules. So this is what we mean by scattered and Stoke and anti-Stoke radiation. So simply Stoke radiation means the frequency of the scattered radiation is lower than that of incident beam. However, as in case of anti-Stoke radiation, the frequency of the scattered radiation is higher than that of incident beam. So here, after this interaction, what we have said that the electromagnetic radiation can induce change in any one of the other. It can induce change in the rotational energy as well as vibrational energy level. So it means either the molecule can excite it from the lower rotational energy to higher rotational energy level, or it can also undergo transaction from lower vibrational energy to higher vibrational energy. So the molecule can excite from lower rotational energy level to higher rotational energy level, or the molecule can also undergo transaction from lower vibrational energy level to higher vibrational energy level. So it means that our Raman effect, this Raman effect deals with both rotational as well as vibrational spectroscopy. So it means that our Raman effect deals with both rotational and vibrational spectroscopy. It means this Raman effect can induce change in both rotational as well as vibrational energy level. Therefore, we have to study about two branches of Raman spectroscopy. One is our Raman rotational spectroscopy. Another one is our, I can say, Raman vibrational spectroscopy. So this is all about the introduction of our Raman spectroscopy, how Raman spectroscopy arises, and on what phenomena, on what basis our Raman spectroscopy arises. So here, the important here is how the scattering of this electromagnetic radiation occurs. कैसे आपका लाइट जो है स्ट्राइक होने के बाद स्केटर होते हैं. स्केटर दो तरीके से हो सकता है. एक इलास्टिक है जिसमें एनर्जी एक्सचेंज नहीं होते हैं, एक आपका इनइलास्टिक है जिसमें एनर्जी एक्सचेंज होते हैं. अब आपका डिपेंडिंग अपॉन द मॉलिक्यूल की आपका स्ट्राइकिंग पार्टिकल्स मॉलिक्यूल है या इलेक्ट्रॉन है, आपका रिले स्कैटरिंग हो सकता है, इलेक्ट्रॉन है तो कैम्पटॉम इफेक्ट हो सकता है। कैम्पटॉम इफेक्ट हमारा यहाँ पे काम है नहीं, हमारा काम जो है रिले स्कैटरिंग पे है। रिले स्कैटरिंग में क्या हो रहा है कि अगर रिले स्कैटरिंग खुद होते हैं तो वहां पे आपके बिल्कुल भी एनर्जी एक्सचेंज नहीं होते हैं। लेकिन कभी कभी क्या होता है, 1 in a million, ये रेयर केस आपका चेंज हो जाता है। अब आपका जो इलास्टिक स्कैटरिंग है वो इन इलास्टिक में चेंज होते हैं। यहाँ पे इलेक्ट्रोमैग्नेटिक रेडिएशन मॉलिक्यूल से स्ट्राइक करने के बाद उसकी एनर्जी या इंक्रीज होते हैं या डिक्रीज होते हैं, तो इस फेनोमेना को हम कहते हैं रमन इफेक्ट। और इसी रमन इफेक्ट के बेसिस पे हमारा रमन स्पेक्ट्रोस्कोपी अराइज होते हैं। अब रमन इफेक्ट दोनों आपकी रोटेशनल एज वेल एज वाइब्रेशनल स्पेक्ट्रोस्कोपी एनर्जी लेवल्स दोनों पे इफेक्ट करते हैं। तो हमें आगे दोनों रोटेशनल स्पेक्ट्रोस्कोपी एज वेल एज वाइब्रेशनल स्पेक्ट्रोस्कोपी पे रमन इफेक्ट का इफेक्ट देखना। ठीक है। सो आज की लेक्चर में हम इतना ही डिस्कस करेंगे। आगे हम देखेंगे इनका क्या इफेक्ट होता है। और दूसरा इंपॉर्टेंट यहाँ पे आपकी पोलराइजेबिलिटी का कंसेप्ट है, जो कि रमन स्पेक्ट्रोस्कोपी में बहुत इंपॉर्टेंट कंसेप्ट है। आगे हम उसके बारे में देखेंगे। सो आज के लिए इतना ही। थैंक यू।